everyone, George here, and we are back again working with procedural textures, and now we're moving on to volume rendering, which is, I must say, one of the most awesome things you can possibly do in 3D graphics. If you thought normal polygons are great, wait till you see what you can do with volume rendering. The problem is, of course, that coming up with data is kind of difficult, but hopefully we will see through this series that we can use some pretty interesting stuff and create some very interesting imagery. Leading off from the last video, we'd of course created a transparency version of our shader that allowed us to pretty much cull information based upon its value, whether or not it was dark and so forth, or how dark it was. But once again, we're only sampling at the surface of the object. That is where the polygons actually are. We need to create lots of polygons all lined up to sample a lot of the internal structure to give our objects some volume, some life, so to speak. So let's go ahead and stop this and begin creating that. Let's create a new class, Assets, right-click, Create, C# Script, and I'm going to call this Plane Generator. Double-click it, open it up in your IDE of choice. And now that we have Plane Generator, I'm just going to close everything else out for a second. Zoom on in a little bit. Now we're going to need a couple different things. The idea behind this class is, in this video at least, we're just going to be generating planes across one axis, and that's going to be our x-axis. In the following videos, we're going to generate the y and z axes, and then we're going to generate ones that are view aligned, and then after that, at some point, we're going to go into ray casting and see, how to do this all inside of a shader without even sampling any planes. But that's still a bit off. We're going to need a few things. Obviously, we're going to need to apply a material to each of these planes, so we might want to go ahead and create that or declare that. So let's do a serialize variable, serialize field, and call this material. Next up, we want the dimensions of what our volume is actually going to be. So we'll do another serialize field, but let's do a vector3 and make this dimensions. Now the dimensions are how high, deep, and wide we're going to create these planes. Now we're also going to need to know what the spacing should be between each plane. And you can do this two different ways. You could say, okay, I want to have a set number of planes, or I want to have a plane every increment. The reason why I'm going to end up doing this with spacing is because if we ever get into medical imaging, which I might do in this video series, you're going to end up being told exactly how many millimeters or centimeters each scan is between one scan and the next. And when you deal with that, it's much easier to work with a spacing value than it is to try to figure out exactly how many planes were taken. So with spacing, I'm just going to set this to something like 0.01 for right now. And then finally, I'm going to create a game object, and I'm going to call this xplanes. Now this is going to be the game object where all of the child planes get placed. Now the next thing I need to do is actually generate the texture that I'm dealing with. So we're going to actually make a spheres class, and we're going to do spheres, and we're going to grab that during start. So now within start, let's go ahead and do a few things. We're going to do spheres is going to be equal to get component, and let's call this spheres. All right. So now let's go ahead and create our game object for xplanes. So xplanes is going to be equal to a new game object, and we're going to just call that xplanes. There we are. So that's it for start. So now let's create a function that we can call called void, void create xplanes. And this one's going to be responsible for pretty much putting most of the stuff together. It's going to iterate over all the planes that we actually need, and then it's going to call another method which is going to do the dirty work of creating the vertices and the UVs necessary to sample things. We're going to need to know where we're going to start and when we're actually going to end inside of our volume. So let's do a vector3. Start is going to be equal to a new vector3. And we're going to begin at since we're dealing with the x dimension, we're going to start at the end of the x area, which is negative dimensions.x. And then of course, we're zeroed out in the y and the z. And because the dimension is the full size of it, we need to divide that by 2 or multiply it by 0.5, completely up to you, one way or the other. Now we need the end, and the end is going to be on the opposite side, so it's going to be another new vector3, and instead it's going to be it's going to be positive dimensions.x, and once again 0.0f, 0.0f, And of course, it needs to be half that distance again, so there we are. Now we need to figure out how many planes we're going to generate based upon that spacing value. So we'll do int number of planes is going to be equal to, typecast this over to an int because we're going to be doing a division, and let's do dimensions dot x divided by our spacing. And that's exactly how many we're going to end up creating. Now we need a for loop that's going to iterate through the number of planes we plan on creating. So we're going to do a for int I is equal to 0, I is less than number of planes, and then I plus plus. And let's see, I need to spell this correctly. There we go. Now the way this is going to work is that we have calculated our start and our end point. Now what I want to do is from that start point, which is really the center of our volume as far as the Y and Z part are concerned, but the very farthest point on our start, I want to slowly increment through that volume bit by bit, multiplying by my spacing size by whatever value I happen to be on in I. And that's going to slowly move me throughout the volume, and I'm going to put a plane at each of those locations. So let's do a vector 3. I'm going to call this my center point. Is going to be equal to start plus a vector 3 dot right, because we're moving towards the right from the left, times whatever my I value is times my spacing. Now I also need to figure out what my UV offset is. Remember, my UV coordinates are from 0, 0, 0 to 1, 1, 1 in three-dimensional space. So I'm going to do float UV offset is going to be equal to 1.0f divided by the number of planes that I have. Once again, that's starting from 0 to 1, dividing by the number of planes tells me how far each increment ends up being. And then I'm going to multiply that by whatever increment I happen to currently be at. So that's how far through the X part of the UV coordinates I happen to be. Now I need to actually create my plane, which we'll leave right there. Then after that, I need to, once the plane is actually generated, I need to apply that as a child object. So let's actually create a game object plane right now. And we're going to do plane.transform.parent is going to be equal to our xplanes.transform. We still need to create that plane. So let's jump on down and create a new method that's going to handle this. Now the reason I'm not just going to put all the code in here to generate it is in the following video, we're actually going to extend this into the not only the X direction, but the Y and the Z. And I want this to be easy enough to where I just make a couple different methods for creating X, Y, and Z, but they all use the same generate plane function to make it happen. So let's do a new method that returns a game object, which is going to be our plane. It's going to be called create plane. And for right now, it's going to take in that center point that we happen to be starting at. So we'll do center point. And then it needs our float UV offset as well that we calculated. And it needs our float off UV offset that we calculated. And with that information, we should be able to move on without needing anything else. So the first thing is we need to create a new game object. So let's do game object temp plane is going to be equal to a new game object. So let's go ahead and create a mesh filter. Mesh filter is going to be equal to temp game object, or excuse me, temp plane dot add component mesh filter. And next up we'll do a mesh renderer. Mesh renderer is equal to temp plane dot add component mesh renderer. Then finally we're going to generate a new mesh, which is going to hold this plane's mesh. Now, do note one thing that I'm doing. I am not creating one mesh with all of the planes in it. That's going to cause all kinds of problems with transparency issues. Instead, every single plane has to be its own game object so that they're sorted properly when it renders the scene from back to front. Now, of course, we need our vertices and our UVs and our indices. So let's do vector 3, array of vertices, equal to new vector 3, and we're only going to have 4 vertices per plane. Then we can do a list of vector 3 UVs, and we have to do a list because we're dealing with 3-dimensional UVs. We can't use the standard variable, we just set the UVs equal to the 2-dimensional ones. Let's do int array indices is equal to a new int and make that also of size 4, specifying the 4 corners. I have that center point, and I'm going to create offsets that move us to the left side and the right side and the top and the bottom of it to transform that center point into all of the different vertices and UVs that I need. So let's create that. Let's do vector 3. I'm going to do offset lower left is going to be equal to a new vector 3. And this is going to be, let's see, 0.0 in the x. Then it's going to be a negative half dimensions dot y. And then it's going to be half dimensions dot z. Now I'm going to create offsets that are going to get me from that center point to the left, right, and top and the bottom. For that, I need to know my half dimensions. That is half the size up and down, left and right. So let's do a vector 3 half dimensions is going to be equal to my normal dimensions divided by 2. Now I can do a vector 3 offset lower left. We're going to be doing an offset for each of the 4 corners. And we're going to do a new vector 3, and this offset is going to be equal to 0.0f in the x, then a negative half dimensions in the y. So we're going down, and then we're going to move over in the z half dimensions dot z. Let's copy this line, paste it 4 times for each of them, and now rename things. So now we're in the lower left. Now we're going to move to the upper left, and then we're going to go to the upper right, and then finally we're going to end up at the lower right, coming all the way back around. Zeros for all the x still, because that's the current value we're on. Where the offset, where we are in x is determined by that center point that keeps getting incremented up here. It's really these values that end up changing to make everything offset. So the next one is upper left area, therefore it's both positives. Then we're going to move to the upper right area, which means that our z value actually needs to be negative. And then finally, the lower right has negatives for both the y and the z values. Now we need to do the same thing except with the UVs. So let's copy these 4 lines because we also have 4 UVs, and we're just going to rename things. So we'll do UV offset. I'm going to copy that and paste that a few times and make that capital, just so that we have a common naming convention going on here. Perfect. We need to make sure that these match these up here. So in this case, we're at the lower left, which means we're going to end up being 0.0 here because that's a negative value, but this is a positive, which means that this should be the furthest out, which is a 1 value. Down here, we have both of these as being positive, therefore they're at the maximum, which is 1.0 in UVs. And then here we have a maximum value, which should be 1.0, and then this should be 0.0 because it is a negative value, the furthest one down. And then once again, these should all be 0.0 and 0.0. Great. And now, for the hard part, we just need to take these points and assign them to our vertices, our UVs, and our indices. So let's do vertices, element 0, is going to be equal to the center point plus our offset lower left. Now we do that for our UVs with UVs.add, and let's do UV offset lower left. And then finally our indices, which is dirt simple. So indices 0 is going to be equal to 0. Now we just copy this and paste it 3 more times and make some changes, following exactly what we did up here. So here, vertice 1 and indice 1, vertice 2, indice 2, vertice 3, indice 3. Now it's center point plus offset dot upper left, and it's UV offsets upper left. And then the next one is going to be upper right. Same thing here, upper right. And then finally, lower right. And we've created our plane all the way around for the x-axis. Now we just need to assign these things. So let's do our mesh.vertices is going to be equal to our vertices. and then our mesh.setUVs. Once again, we have to do set UVs because we have these three-dimensional UVs. We're going to do it channel 0 and do UVs. Next up are our mesh.setIndices, and that's going to be our indices, and we're going to do mesh topology.quads, and it's going to be subchild 0. Now we can set our mesh, so we'll do mesh filter dot mesh is equal to mesh, and then our mesh renderer dot material is equal to material. And finally, we get to return our temp plane. All right, coming back up here now, we actually do the right thing. And game object plane is going to be equal to create plane. And we pass in our center point, and we pass in our UV offset. Now with that done, we actually need to hook up what happens here with our generation of our texture, our 3D texture, because right now, nothing's going to generate our 3D texture. If we come over here and we double click on spheres, bring that over to the other side here. Right now, inside of start, we generate our texture right here. However, the generation of our texture is being done with a coroutine. We need to know when that coroutine ends, and we can't be guaranteed on when that actually is. So something needs to inform the plane generator that, hey, a texture is ready to be assigned. Please assign it now that it's complete. And we're going to use a delegate and an event to make that happen. So in our spheres class, let's declare our delegate and event. So coming up here, we'll do a public delegate void, and we'll call this, let's see, spheres calc complete. And then we're going to do our event, which is a public static event. And then we're going to do on spheres calc complete. Oh, whoops, we got to put the type here. So static event sphere calc complete on spheres calc complete. And this is a method type, so make sure you put the parentheses on the end. Now we're going to grab our onSpheresCalc complete. And when do we call this? Well, when we're finished actually creating our spheres. So we're going to go to and create spheres all the way down to the bottom when we're completely finished. And we're going to do onSpheresCalc complete. And what we need to do is to see whether or not that's null. It's null only when no one has subscribed to the event. So if it's not null, someone has subscribed to it. Therefore, we can actually call onSpheresComplete. And if you haven't worked with events before, basically what this is going to do is anyone who's subscribed to this event is then going to be notified. So what we're going to do here is instead of doing material right here, we're going to get rid of that entire line. And coming back down, we can get rid of grabbing the material. That's not going to be needed because we're not attaching this to the object itself. And coming down further, we're not going to do material.setTexture there either. We are going to generate the texture though, but we're going to inform someone that, hey, it's finished, come and grab me. So coming up here, texture 3D, I'm going to right click on this, quick actions and refactoring, and I'm going to create a property. And I'm going to make a getter for my texture 3D. Now I'm just going to come down here and you'll notice that it went ahead and replaced texture 3D everywhere else. I just need to go through here and make sure I'm not getting any errors anywhere. Looks like I'm good. Sounds great to me. And now we can jump over here and create our function to handle this event when it occurs. Now what kind of a function we need? Well, we need a function with this kind of signature. That is a return type of void that takes no parameters. So over here, I'm going to do void. I'm going to call this on spheres calc complete. I like to call it the same thing. So when this actually occurs, what are we going to do? Well, we are going to grab our spheres object, spheres, and we're going to do texture 3D, right? So let's go ahead and take our material and do material dot set texture. And the texture's name, or the shader property is underscore main text that we're referring to. And we'll do spheres.texture3D, parenthesis, there we go. And that's all we need for right there. Now all we need to do is inside of start, after we have done this, we've created our new game object, we should go ahead and call our spheres stuff. So let's call our coroutine create spheres. Now rather than call the coroutine on that, I'd rather create a function. So I'm going to do a public void create spheres. And this is just going to start coroutine, and that's going to be create spheres. Now I can come over here and on spheres dot create spheres. Great. That should do that for me. Now what is the problem? Oh, it has the same parameters. Oh, that's right. The return type is not part of the parameter list, so that won't work. So I need to create a different name. So let's just call this generate spheres. I'm going to turn off this coroutine up in start so that doesn't happen. And let's call this that. Perfect. Once the spheres are created, this happens. This is going to go through the IEnumerator. Occasionally it's going to stop and allow other things to process. It's going to finish everything up. It's going to call the function that I've registered, which I need to still register. I actually need to do spheres dot on sphere calc complete plus equals on spheres calc complete. So that's assigned this method I've created. It's subscribed it to this event that occurs. So when this happens, this now gets called. Now, once we have the texture finished is when I'm going to wait until I create my X planes. Because now I know that everything's generated and I can move on to creating my planes just to make sure everything's okay. So with that, why don't we come back out here? Looks like we don't have any errors for the moment. And we're going to go to our cubes here. So let's go ahead and delete our cube and our sphere. And I'm going to go to game object, create empty, and put that at the 0 point. And let's go ahead and put our spheres on there. And it looks like spheres right now requires a mesh renderer and a mesh filter, which we don't have a requirement for anymore. So let's get rid of that. So coming up over to spheres, we're going to get rid of these two that aren't necessary anymore because we're not just working with polygons. Let's go ahead now that we've gotten rid of that, remove those components. So let's see, remove and remove. And under game object, let's just call this plane generator and put the plane generator on that as well. Now it asks for the progress text, so let's put that there. And it also asks for the material we're working with, and really the material we're working with is still the texture 3D, which is called checkerboard still, so I'm just going to drag that over there. And actually, instead of calling this checkerboard, I'm just going to call this texture 3D, because it will work with any 3D texture now at this point. And let's go ahead and hit run and see what happens. So progress is still in progress right here. Oh, you know what? This isn't going to do anything. So there are a couple problems right here already off the bat. So let's go ahead and see what's going on. Now, part of the issue is the fact that colors hasn't been created yet. And that's because the start method over here ended up getting called before this start method over here actually fired. So we can see right there, generate spheres. So what I'm going to do is move all of this stuff into the awake method for spheres. That's just going to make sure that all this gets set up beforehand. Now let's come on back and see what else. So it says mesh filter. There is no mesh filter attached, so let's check that one out. And that's on spheres. And once again, this is just a relic from what we were doing before. We don't need this stuff anymore. So this no longer needs to continually calculate what the vertices are. So we're going to get rid of calculate 3D UVW. And actually, we don't even need this update function anymore. We're going to get rid of that completely at this point. Coming back over here now, let's clear this out. And under plane generator, we have our dimensions equal to 0, 0, 0, which isn't going to help me at all. So let's set them instead to 1, 1, 1, because if you think about it, it's going to do 0 iterations if there's nothing to iterate over. Now, before we continue, one thing I haven't done is I did not name the planes, so I should probably do that. So when I do, let's see, game object temp plane equals new game object, let's call this instead plane, and then we'll do plane, and then add to that our center point dot toString. Why not? And actually, going through this, there is one other big problem that I completely missed, and that is the fact that indices should be equal to 0, 1, 2, and 3. Otherwise, it's going to be the same point over and over again. So now, let us go up here and rerun this thing. And it's processed all the points. Perfect. Moving on. And there is our volume of stuff. So let's take a look at it. Those are our planes. And it looks like, Well, it looks like we might have a problem with the UVs from what I'm seeing here. I'm not seeing a whole lot. And most likely we're being generated in the wrong place. So let's turn this off and take another look over here. And it looks like there is one thing I forgot to do. And that is right now we're not offsetting the UVs by how far along they are in the X UV coordinates. I actually need to use vector 3.right and multiply that by whatever my current UV offset happens to be. Now that combined with the left, right, up and down offsets should make everything perfect. What the problem was before that, it was always putting the same UV coordinates for each point. Now I should be getting distinct UV coordinates ranging all the way through the x-axis. And here we go, pretty neat. So we've got a volume display of all of those different points, but you'll notice some problems with this. If we take a look at it from our side, our glancing view, you'll see that we can see between the planes. And that's a problem with the fact that this is axis aligned. Now, of course, we could try a different axis, and then if we used a little bit of math, depending upon which side we happen to be looking on, we could have it swap from one axis to the next. And we are going to eventually get there and take a look at that. But hopefully in this series, we eventually get to ray casting, which means we actually cast rays into the volume and calculate what this thing should look like through those rays. But anyway, let's try to make this look a little bit nicer. I'm going to go in here and increase the density by going to spacing and make that 0.001. So increasing it by a factor of 10. Go ahead and hit run. And let's see here. So went all the way up, created all that stuff. I should probably now create something that shows me how far along in the x-axis I am, or the x generation I am. And you know what? That's actually doing pretty well. A lot better. We can clearly see the planes. We can clearly see the pixels actually in this case. The planes now, it looks like, are quite a few more than the actual pixels that make up the image. So let's go to our texture 3D material. And what's interesting now is we can clearly see what we had before. So there's the volume, and then as we slowly get rid of that transparency, you can see it eroding away those values. And then of course, there we are down with nothing. And you'll notice that having a little bit of those gray values in there really helps to kind of make the things pop. But anyway, I hope you enjoyed this video. Volume rendering is a pretty interesting kind of thing. You can do a lot of crazy stuff with it. And hopefully we will expand this series and do a lot more. I will see you all next time. So long and goodbye.